child node, leaf node, internal node, external node, or the depth of the node of the tree, height, then the path. Okay, so here 7, this is a root node because the tree has only one root node and 7 is the first node of this tree. Okay, so how many nodes are here, parent node, or how many nodes are internal node? Look at the structure. This 7, 5, 10, 14, 4, these nodes have children. That's why they are internal node. And the nodes 2, 9, 11, 1, 3, they are leaf node or external node because they don't have any children, right? And now if I ask you what is the depth of this node 4? What is the depth of the node 4? How we can calculate the depth of a node? What is the depth of node 4? Or what is depth? We discussed these things in the last class, isn't it? How to find
Yes,
out
ma'am.
the depth of a particular node? Is there anyone who can tell us that this is actually depth of the node 4? What is the process of calculating the depth?
For finding the depth of a node, we have to determine how many data are below that one.
How many data are
below that one? Yeah, like there is 1, 3, but both are in same class, so we can consider 1.
the depth of the node 4 is 1.
Yes, ma'am.
Okay, what about the others? Is it correct that the depth of 4 is 1? Okay, so let me just recall all those features again. This is a data structure tree which has only one root node, that is 7. And here 7 has 2 children, one is 5 and 4. That's why these are child node of 7. And here 2 and 14, they came from which node? 5 node. The node 5. That's why 5 is the parent node of 2 and 14. Isn't it? And then there is another term which is internal node and external node. What is internal node? Here 7, 5, 10, 14, 4. These 5 nodes have some children, and the children's number can be 1 or 2, so that, or more than 2. So the node which have children, they're called internal node or non-terminal node. And what about external node or leaf node? The node which doesn't have any children, such as 2, 9, 11, they are called leaf node, terminal node, or external node. Okay, so here how many nodes you can see here total? 10 nodes, isn't it? 7, 5, 10, 2, 14, 4, 9, 11, 1, 3. So here n equals to 10. In tree data structure, each data element we can call them as node. So for connecting or for creating the relationship among those 10 nodes, how many links we need? N minus 1 number of links, or h. So what is h? The link between two nodes is called h, right? So here this link connects two nodes, that is 7 and 5, and in the same way this link can connect 5 with 14. So the h or link is the connection between two nodes, that is called edges. For n number of nodes, we need how many edges? N minus 1 number of edges. Okay. So now if we want to find out the height of any node, how we can do it? Suppose we have to find out what is the depth of the node 14. So how we can calculate it? Here, if we want to find out the depth, then we need to consider the leaf node, which is placed in the last level of this data structure. And what is level? Each of these data elements are placed in some hierarchy or some level. For the root node, the level number is always 0. We have to start from which level? From level number 0, isn't it? And here from top to bottom, the level number will be increased by 1. That means this data element 5 and 10, they are placed in the next level, which is 1. The level number is 1. What about 2, 14, and 4? They are placed in another level, isn't it? And what will be its level number? Just
Yes, ma'am. It's
increase
level two.
the number by 2. So they're in the level number 2, and the last level is here where we have taken 9, 11, 1, 3. That is our level number 3. That means this data structured tree has how many levels? 4 levels starting from 0 to 3, isn't it? So now if we want to find out what is the height of the node 14, so at that time we need to know which leaf node is placed in the last level. So there are total 4 leaves in the last level, that is in level 3, 9, 11, 1, 3. But these two nodes are not related with 14, isn't it? So if we want to calculate the height of any node at that time, we have to consider a leaf node and that node 14. Okay, and now between these two nodes, how many links or how many edges we can find? Only one edge. That's why the height of 14 will be 1, and this is same for 4. This 4 is connected with 2 leaf node, which is placed only one level, and that is our the last level, level number 3. So between these two nodes, between the leaf node 1 and between this node 4, there is only one edge. That's why the height of that node is 1. Okay, then what about the height of this entire tree? The height of the tree is actually the height of the root node, because root node is placed in the first level and we are taking the leaf node from the last level. So this is the longest path. Okay, so between these two nodes, between the root node and this leaf node, how many edges we can find? 3 edges, and that is the height of this tree. Clear what is the height?
Yes, ma'am.
Yes, ma'am.
Okay, then Ashik, you said that the depth of 4 is 1. Is it true?
No,
It's
ma'am.
not
It should be
true.
2. Yes, ma'am. Got it.
Yeah. So how we can calculate depth now? Instead of taking the leaf node as a reference, we have to take the root node if we want to find out the depth of any node. So here the root node is 7. Now we have to count how many edges we can find between that node 4 and the root node 7. There are 2 edges. That's why the depth of the node 4 is 2. Is that clear?
Yes, ma'am.
And what about the node 9? 9 is the leaf node
Yes, ma'am.
from the bottom's level. Okay. And between the root node 7 and that leaf node 9, there are 3 edges. That's why the depth of node 9 will be 3.
3.
And when we are calculating or when we are counting the number of edges for the whole tree, at that time we saw that the height of the root node is actually the height of the tree. Okay, but in depth, when we are calculating the depth of the tree, we need to consider the leaf node from the last level. So here from this level, if we take any of this node 9, 11, 1, 3, and then if we count the number of edges between the root node and that node, we will find the depth of the tree. Is it clear what is the depth of the tree?
Yes, ma'am.
So for
Yes,
the
ma'am.
leaf node 3, there are 3 edges between root node and that leaf node. That's why this is the depth of this tree. Okay, and another term we use, that is the path. What is path? Suppose our source node is 5 and we want to visit the node 11 from that node 5. This is our source node and this is our destination node. In how many ways we can visit that destination node from the source node? There is only one way, from 5 to 14 and then 14 to 11. So the path between two nodes is the possible all the node and all the edges between that two node. So here the path sequence is 5 to 14 and then 14 to 11. This is our path between the node 5 and 11. And what is the length of this path? The length is the number of nodes in that path sequence. And here there are 3 nodes, 5, 14, 11. So the path length is 3. Is it clear?
Yes, ma'am.
Okay. And then we discussed about some types of tree. That is when you can call the tree as binary tree or when you can call it full binary tree or complete tree. So look at this structure. Is it a binary tree or is it just a tree or it's complete tree? Which one it is?
Just a tree.
It's just a tree.
Yes,
What
ma'am.
about the others?
Yes, ma'am. It's just
It's
But
it's a
actually this is a binary tree. This is a tree but we can call it binary tree. Why? Because the definition of binary tree is a node can have 0, 1 or maximum 2 children. So here among those 10 nodes we can see that these nodes have 0 children, and there are some nodes who have 2 children. So this is actually a binary tree. Is it clear? This is a binary tree, and the definition of binary tree is each node can have 0, 1, but maximum 2 children. If in this structure any node, if that node has suppose 3 children, at that time we cannot call it binary tree. So it will be just a general tree. Okay. So now if it is a binary tree, now we need to know in how many ways we can traverse a tree. Just think about array traversal. Suppose these data items are stored in an array, and suppose we
binary.
have taken suppose 5 elements, 7, 5, 2, 12, and then 11. So how we can traverse this array? Or what is
One
traverse?
after another.
Very good, one after another. Traversal is an operation of data structure. And what is traversal? That means processing or accessing or visiting each node exactly once. And if it is a linear data structure, we can start from the first location and then we can conduct a loop for visiting all the nodes linearly or sequentially. At first, we will visit the first node from the location 0, and that node is 7. And then we can traverse the second data element, which is in location 1. So 11 equals to 5. In this way, we can visit each node exactly once. So traversal means just accessing the nodes. How many times? Only once. So in this nonlinear data structure, how we can traverse all nodes from this tree? How many times? Only once. After the traversal, we have to visit all these nodes. So which methods we can apply? So in tree data structure, there are 3 ways for traversing the elements, and they're called pre-order traversal, post-order traversal, and in-order traversal. So there are 3 types of traversal method. One is called pre-order traversal. After that, post-order traversal, and the third one is in-order traversal. Okay. So now the first one is pre-order traversal, and how we are actually giving the name, that is pre-order, post-order, in-order, based on the appearance of the root node in that traversal sequence. Okay, so based on the position of the root node, we are categorizing or we are actually naming the traversal methods in this way: pre-order, post-order, and in-order. So the first one is pre-order traversal. That means at first which node will be traversed, which node will be visited, the root node. In pre-order traversal, at first the root node will be visited, then you can decide which subtree will be visited first. That is a left subtree or the right subtree. And what is left subtree and right subtree? We know that in binary tree, the maximum number of children of any node is 2. That's why one child is called left child, that is in the left side of that root node. That is the left child of 7, and 10 is the right child of 7. So this portion is called the left subtree, and this portion is called the right subtree, isn't it? Right?
Yes, ma'am.
Yes, ma'am.
Okay, so in pre-order traversal, what will be the sequence for traversing these elements? At first, the root node will be traversed, and then the left subtree will be traversed, that is the left side of the tree, and then the right subtree will be traversed. That is the method we can use in pre-order traversal. Okay, so now this is our this is a tree, right? So in pre-order traversal, and traversal means accessing each element exactly once, and in this method, pre-order traversal method, we will traverse the root node first. That means after applying this method, we can take the element 7. That is now the 7, this item is visited now, isn't it? So after that, we have to process which subtree of
Five.
this feature, the left subtree. That is 5. But here in this side, in this left subtree, at or when we are actually processing a data from or processing a node from this subtree, we have to find out whether that data item is a root node or not. Look at the subtree again. The first step of this traversal method is visit the root node. Okay, and then step number 2, traverse left step, we have to use a recursive function. That means here the 5 is a left node of 7, but 5 is also a root node because 5 has two children, 2 and 14. That means in this subtree we are calling this function pre-ordered again and again until we got a leaf node. Is it clear? The first one is we have to visit the root node, that is 7, and then we can traverse which subtree, left subtree. And in this left subtree now again we'll use a recursive function, that is the pre-order function, where we have to traverse the root node first and then the left child, after that the right child. So here after taking 7, now this is our next node 5 because it's placed in the left subtree of that root node. But here 5 is not a leaf node. 5 is a parent node which has two children. One is the left child, another is the right child. That's why we cannot 5 here because we are using a recursive function pre-order where the sequence is root, left, right. So here the root is 5. So can we take 5 now?
Yes, ma'am.
Yes, we can take 5. Okay. Then what is the process after processing the root node, then the left child of that node? So 2 is the child node of 5. Is it a parent node?
Note.
It is a parent node? No.
No, ma'am.
This is a
Madam, it's leaf note.
That means we can take that left child of the root node 5. After taking the left child, now we have to take the right child of the root node 5. That means now we are again traversing back here 2 to 5. Okay, so now from this root node we can move on to the next node, that is 14. So 14 is the right child of 5. So can we take 14 now? 14 is also a parent node, but we can take 14 because this is pre-order traversal method. That's why take the root node first, after that the right child, and then the left child, and then the right child. After taking the root node 14, now we can take the left child of that node 9, and then the right child of 14, that is 11. Is that clear? In pre-order traversal method, at first traverse the root node and then traverse the left subtree, then traverse the right subtree. So now here we have traversed all the elements of the left subtree, isn't it?
Yes, ma'am.
Yes, ma'am.
Yeah, so what will be our next step? Now we can traverse the 7 elements. After traversing all the steps, now we can traverse back from 11 to 14, but we cannot take those elements here because we already taken 14. And 14 to 5, 5 to 7, now we can move on to the next data element, which is placed in the right subtree. So here, parent node 10, yes, it's a parent node, so we can take 10, which is the root node of the right subtree. So after taking it, now we can take the left child of 10, but 10 doesn't have any left child, right? This 10 doesn't have a left child, so now we can take the right child of that node, which is 4. So it's also a root node, so sorry, parent node. So after taking 4, we will take its left child 1, and then the right child of that node 3. So how many elements we have taken in this sequence? Total 10 elements. That means all the elements of that structure is traversed. Is it clear what is pre-order traversal method? Yes. This is a method where we can access each node exactly one time. And here in this traversal method, we have to follow this sequence: root, then left, and then right. at first traverse the root node and then the left subtree. In that left subtree again we can call that recursive function that preorder. Okay, then we can traverse the right subtree. So if it's clear to you, then I'm giving you another structure. Just try to find out the sequence. Okay.
Hello, ma'am.
Yes. Yeah, I'm just giving you a problem. I'm just giving you a tree, and you have to find out the sequence of pre-order traversal. Okay. Then 35. Okay, so here you have to apply pre-order traversal method. Okay, so just find out the sequence of pre-order traversal. So is this a binary tree?
Yes, ma'am.
Yes, ma'am.
The binary tree. Okay. So this tree has two subtree. One is left subtree and another is right subtree. And the traversal method is pre-order. That means at first traverse the root node and then the left subtree. After that the right subtree.
Done, madam.
Done. Very good. Okay, so tell us the sequence.
20,
20, 15, 10,
15, 10,
18,
18, 17, 15,
15,
10,
10,
18,
10,
17,
17,
30,
30,
25,
25,
40,
40,
35,
35,
38, and 50.
38, 50. Oh, sorry, I couldn't write it because someone was in the waiting room, so I just missed some of the notes. After 40, the note is
35,
35,
38, 50.
38, and 50.
38 and then 50. Okay. So is this correct sequence?
Hope so, ma'am.
Yes, ma'am.
Okay. So now we can check whether the sequence is correct or not. This is pre-order traversal and which method we're going to follow. Root, after that left subtree or left child, and then the right child. Okay, so here which one is a root node? 20. So at first we'll traverse 20. Okay, then 15 is a left child, or this is a left subtree of that tree, and 15 is a parent node which has two children. So at first we will take 15 and then its left child is 10, but it's not a parent node, so we can take its value, right? 10. After that you can traverse the right element of 15. So 18 is a right child of 15. So after taking it, now you can see that it's also a parent node which has only a left child, that is 17. Okay, so after traversing the left subtree, now we can traverse the right subtree. In this subtree, at first we'll take 30. This is the root node or parent node of 25 and 14. After traversing the root node, then we can take the left node 25. It's not a root node. Then we can take the right child of 30. 40 is the right child of 30 and it's also a parent node. So after taking 40, we can take the left child of it, that is 35. Okay, so after traversing the left child of 40, can we take the right child of 40? No, because 35 is also a parent node which has a left child 38. So after taking it now, we can take the right child of 40. That means this sequence is correct. Clear?
Yes, ma'am.
Yes, ma'am.
Okay. So I hope pre-order traversal is clear to you. Okay. So now we can use the next one, that is in order traversal method. So what should be the sequence in order traversal method? Which node will be traversed first? This name is given based on the position of root node. And what is the name of this traversal method in order? That means the root node should be placed between left subtree and the right subtree. So in order traversal method, at first left subtree will be processed, and then the root node, and after that right subtree. Clear? In the previous one, in pre-order traversal, the sequence was root, left, right, but now the sequence is left, after that root, because it's in order traversal, and then the right node. Okay, so now if we apply this method, which node will be traversed first? We'll start from the root node. 20 is the root node because it has some children, or it has some parent. Sorry, it's a parent node because it has some children, 15 and 30. So we can't take it because the sequence is left, after that root, and then right. So now 15 is our current root node. Is it a leaf node?
Yes, ma'am. No, madam. Parent node.
No, it's not leaf node. It's a parent node because it has two children, 10 and 18. So which children will be taken first, will be traversed first? The left one. Look at the sequence. Take the left child first. So we will take 10. After that, root. So 10 for 10, the parent node is 15. The root node is 15. So after taking the left child, we will take 15, which is the root node. And then the right node, the right child of that node 15. Which one is the right child? 18. But 18 is not a leaf node. It's a parent node or a root node which has a child node. So can we take 18 now? No. Because look at the sequence, left, root, right. After taking 15, now when you are about to take the node 18, now we saw that 18 is actually a leaf, it is not a leaf node. It's a parent node or it's a root node, and look at the sequence. At first take the left child of that root node and then you can take the root node. So here 17 is the left child of 18. After taking it, we can take the root node. Left, after that right, and then root and then right. But 18, it doesn't have any root node. That's what I'm saying. It doesn't have any right child. So what will be our next step? The sequence is left, root, and then right. Okay, so after starting from the root node, we didn't take it because it's a root node. The sequence is at first take the left node. So 15 is the left child of 20, and it's also a root node. It has two children, 10 and 18. That's why we can't take the root node. So now 10 is a leaf node and it's the left child of 15. That's why we took 10. Now the sequence is after left node, take the root node. For 10, the root node is 15 and we took it. Then the right child. So 18 is the right child of 15, but is it a leaf node? No, it's a root node. And when a root node appears, we can't take it before taking its left and right, before taking its left child. So for 18, the left child is 17, so take it. After that, after taking left child, now we can take the root, that is 18. Then right child, but 18 doesn't have right child, so we can move on to this root node. Now we have traversed the left subtree, right? After traversing the left subtree, now take the root node, that is 20. After taking the root node, now we can traverse the right subtree where we have to again call that recursive function in order. Okay, so in this right subtree now 30 is a node and it is the root node or parents node of 25 and 40, so we can't take 30. The sequence, first take the left child. So 25 is a left child of 30 and it's a leaf node, so we can take it. After taking 25, now we can take root node 30. Okay, so 30 is a root node, and then the right child of 30 is 40, but it's a parent node. Okay, so its left child is 35, which is also parent of the node 38. That's why at first we will take 38, that is the left child of 35. After taking left node, now the root node, that is 35. Then take the right child of 35, but 35 doesn't have a left child. So this was the left child of 40. After traversing this left subtree of 40, now we can take the root node 40. And then right child of 40 is 50, and it's a leaf node, so we can take it. Is that clear? What is in order traversal? The sequence is left, root, right, and we are using this recursive function until we get the leaf node. Is that clear?
Yes, ma'am.
Yes.
Okay, so I'm giving you another structure, the previous one actually. Yes? Now for this structure, try to find out the in order traversal. 7, 5, 10, 3, 10, 6, 9, 11, 1 and 3. Sorry, 1 and 2. Okay, so for this tree now apply no traversal.
25,
Okay? Done.
3, 5, 9, 14, 11, 7.
3, 5,
9,
9,
14,
14,
11, 7.
11, 7,
1, 6, 2,
1, 6,
2,
1, 6, 2.
10, then 10.
Then 10. Is it correct? Is it the correct sequence?
Yes, ma'am.
What about the others? Do you get any other sequence? Okay,
Ma'am, I got the
I
same.
think
you got the same. Happy. Where Ryan Hussain? Hello, Ryan.
Huh?
Hello. You all got the same sequence. This one. Okay.
Madam,
ma'am, I think 7 will be last, ma'am.
7 will be last. Okay, so this is in order traversal, and which sequence will follow here? At first left
Left, root, right.
node will be traverse, then root, after that right.
Right.
Okay. So the first node is 7 and it's a root node, so we can't take it. Then the left child of 7 is 5. It's also a parent node, so we can't take it. Now 3 is the left child and it's a leaf node, so we can take 3. At first take 3, that is a left child of 5, and then root node. And 5 is the root node of 3, that's why we have taken 5. And then the right child of that root node 5. The right child is 14, which is a parent node, and it has children, left and right. Which one will be taken first? The right node, that is 9. Okay, after taking the left node, now take the root node, that is 14, and then the right child of 11. Okay, so now we have traversed the left subtree. After traversing the left subtree, then take the root node because it's in order traversal. So here 7 is the root node. What is the next step? The next step is traverse the right subtree where use the recursive function in order. So here 10 is the right child of 7 and it's a parent node. It has how many children? 1 children. Isn't it? How many children it has? Only 1 children. So does that mean that we can avoid 10? Look at the sequence, left, root, right. Okay, this 10 doesn't have any left child, it's null. Okay, it's empty. That means we can take, after 7, we have to take 10. That is a root node. Here the left child is null, so that means we can't assign any value here. But after that, after traversing the left child of that node, take the root node, which is 10. So here it can be 1. Is it clear? This is a binary tree, so it can happen that in node it doesn't have any left child, but that doesn't mean it can break the sequence. Because this node has a right child, and before taking the right child, you have to take the root node. Look at the sequence, left, root, right. Before taking the right child of that node, take the root node. So after taking 10, now we can, so this is not correct. After taking 10, now we can take 6. Can we take 6? No, because 6 is a root node. 6 has 2 children, 1 and 2. That means after taking 10, we have to take 1, that is a left child of 6, then take the root node 6, and after that 2. So that is the correct sequence. Is it clear now?
Yes, ma'am, got it.
So at first traverse the left subtree,
Yes,
and
ma'am.
then the root node, and then the right subtree. So that was in order traversal. Now the last one, that is pre-order traversal. Sorry, post-order. So let me write the sequence here for post-order traversal. What should be the sequence? The name is post-ordered. So the root node
Root
will be
last.
placed. Very good. So here the sequence is left, then root, right, and then root. So at first traverse the left subtree, then right subtree, after that root node. Okay. So for the same tree, now how we can traverse it in this way, in post order. So the root node is 7 and we can take it. So its 2 children are 5 and 10. So which subtree will be traversed first? So obviously the left subtree, this one. And in this left subtree, the root node is 5. Okay, and it has only 1 child, that is 3. So at first we can take 3. After traversing the left child, now we can take the right side of that root node 5. 14 is the right child, but it's a root node, so we can't take 14 now. At first its left child should be taken, so 9 is the left child, and then the right child, so take 11. 11 is the right child of 14, then we can take the root node 14. So after traversing the right subtree or right child of that root node 5, then we can take 5. So for the root node 5, 3 was the left child. We have to traverse that node first, and then this is the right subtree for that root node, okay? And then we can traverse the root node. Now the left subtree is done. We have traversed all the elements from left subtree. After that we can take 7 because the sequence is left, right and root. So after traversing the left subtree, that traverse the right subtree. And this one is our right subtree. In the right subtree, 10 is the root node, so we can take it, and its left child is null. So which one will be taken first? The right child, 6, but it's also a parent node, so take its left child first, that is 1, and for 6 the right child is 2. After taking the left and right child, now we can take 6. So 6 is a root node, which was the right child of 10. Okay, so now after that we can take the root nodes 10, and this is the right subtree of the root node 7. So after traversing the left subtree and the right subtree, now we can take the root node. Is this clear? This is post order traversal. So traverse the left subtree first and then the right subtree, after that the root node. Clear?
Yes,
ma'am.
Yes.
If it's clear, then try to
Yes,
solve this
ma'am.
one. Done?
Yes, ma'am.
So what is the sequence?
And 3, 4,
4,
6,
6,
5,
5,
7,
7,
30,
30,
38,
38.
that
57,
27,
and 20.
20. So is this correct?
Yes, ma'am.
yes, ma'am.
Very good. So that is the post order traversal of the tree. So 20 is the root node. What is the sequence? Left, after that right, and then root node. So here for 20, 7 is the left child and it's also a parent of the node 3. So take that left child 3 and then take the right child of 7. So 5 is the right child of 7, which is a parent node, so take its left child, that is 4. And after taking left child, then take the right child 6, and then after traversing the left child and right child of a parent node, then we can take that node, that root node 5, and then 5 was the right child of 7. So 3 was the left child of 7. So at first we traversed it, and then the right child of 7, and then the root node 7. So this is the left subtree of this tree of that root node 20. Then traverse the right subtree. So here 20 is parent node of 38 and 38 also parent node of 30. So at first take 30 is the left child of 38. So it doesn't have any right child. So take that root 38, and then 38 was the right child of 27. So take that root node 27. After that the root node of the tree. Is it clear?
Yes, ma'am.
Okay. So that means we can easily traverse any tree in post order, pre order, in order traversal when the tree is given. But can we do the opposite thing? That is, the in order or post order traversal is given from those sequence we have to create the tree. Can we do it? So now the next topic is when a pre-order, and suppose among those three traversal, two traversal sequences are given. One is pre-order and another is in-order traversal. So from that sequence we have to create the tree. Is it possible? Or when only one traversal is given, can we create the tree? Is it possible?
Yes, ma'am, we can try.
Okay, so the example that we have given you before, suppose the pre-order sequence is 7, 5, then 2, 14, then 9, 11, then 10, 4, 1, 3. So this is the pre-order traversal, and how many nodes are here? 10 nodes. 7, 5, 2, 14, 9, 11, 10, 4, 1, 3. So when only one sequence is given, is it possible to draw the tree? Because in pre-order traversal, how we got the sequence? After traversing the tree in the ordering root, left and right. So here 7 is our root node, and this is the left subtree of that root node. So how we can find out that how many nodes are included in the left subtree and how many nodes are involved in the right subtree? It's difficult, isn't it? When only one sequence is given, the way we are actually creating the tree, it can't be a unique tree. Maybe you got a tree where the number of nodes in left subtree is 4 and someone got 5 nodes in left subtree. So at that time, the tree will not be a unique tree. But when two ordering is given among those three, at that time we can create a unique binary tree. Okay, so suppose here what will be the in order? Give me a minute. Okay, so suppose the in-order traversal is also given. Okay, and what is the sequence we follow in in-order traversal method? At first left, then root, and then right. Okay, so suppose the sequence is 2, 5, 9, 14, 11, 7, and then 10, 1, 4, and 3. Okay, so now the pre-order and in-order traversal sequence is given. From this sequence, we have to create the tree. In pre-order traversal method, at first root, and then the left child, and then the right child. For in-order traversal method, at first left, and then the root node, and the right subtree right child. So from pre-order look at the in-order traversal sequence. From this sequence, it's not possible to identify the root node because we don't know the length of left subtree or the right subtree. But from the pre-order sequence, we can say that 7 is the root node because the ordering is root, left, right. So now we can take 7 as a root node, isn't it? So 7 is the root node and we got it from the pre-order traversal method. Now the next step is identify that node in the in-order traversal. So why we can find that node 7 in in-order traversal here, isn't it? And what is the ordering of in-order traversal? Left, root, right. That means here all these nodes belong to the left subtree and all these 3 nodes belong to the right subtree, isn't it? Yes, from the traversal method, we can identify the root node and then find out its position in the in-order traversal and then divide the tree into subtree. These are left subtree and this is the right subtree. And what is the next step? Again, if we want to create the left subtree, we need to find out which one is our root node. But here we use the recursive order function that is left, root, right. So we don't know which one is the root node here. So how we can find it out? From the pre-order traversal. Now we have to find out among those 5 nodes which node appears first in the pre-order sequence. Among those nodes 2, 5, 9, 14, 11, we got 5 first, isn't it? Look at the sequence. Why we got how many nodes are here in the left subtree? 5 nodes. 2, 5, 9, 14, 11. And in pre-order traversal at first we got 5, which means that 5 is actually the root node of the left child of the node 7. Isn't it?
Yes, ma'am.
Okay, now what is the next step? The same process, identify that node in the in-order traversal. So here 5 is the root node. That means we can divide that left subtree into two parts again. This is our left subtree 1 element 2, and this will be our right subtree when the root node is 5. So in this left subtree there is only one node 2, so we don't need to find its position over here. You can see 2. So 2 can be placed as the left child of 5. Okay, so now in the right subtree there are 3 elements, 3 nodes, 9, 14, 11. So which one is actually the right child of 5? We have to find it out from the pre-order traversal, isn't it? From those 3 nodes, 9, 14, and 11, which one can we get first in the pre-order traversal? Which one appears first? Obviously 14, right?
Yes, ma'am.
In those 3 nodes, 14 appears first, which means that 14 is actually the root node in this subtree. Okay, so how many, after that, after taking the root node from the pre-order traversal, now again identify its position in that in-order traversal 14. Right, so here if 14 is a root node, that means 9 is its left child and 11 is the right child of that node 14. So our pre-order, we have taken all the nodes from the left subtree. Okay, so now we can place the nodes in the right subtree. How many nodes are here? 3, 4 nodes, 10, 1, 4 and 3. So which one is the root node among those 4 nodes? We have to find it out from which traversal, from pre-order traversal. So among those 4 nodes, the position of 10 is before 4 on 3, which means that 10 is the root node. So identify that root node in this sequence. So 10 is that root node, right? So before 10, there is no other elements, which means that 10 doesn't have any left child. So 1, 4, 3, these 3 nodes can be placed in the right subtree or as the right child of 10, but which one is actually the root node? Again, we have to find it from the pre-order traversal. So among those 3 nodes, 1, 4, 3, which one appears first? 4, which means 4 is the right child of 10, or now it's the root node. So now find out that node in the order traversal. So if it is root node, its left child will be 1 and right child will be 3. So in this way we can create the tree when 2 orders are given. The ordering can be pre-order in order, or it can be post-order in order, or it can be pre-order post-order. Is it clear?
Yeah, madam.
I'm explaining the process again. If the pre-order traversal and in-order traversal is given, then how we can create the structure? So at first we have to remember the sequence that we use in this traversal method. For pre-order, the sequence is root, left, right. For in-order, left, root, right. That means the first node of this sequence is the root node of the tree, 7. And then identify that node in the in-order traversal. Okay, so when we found that node, that root node, now we can easily divide the tree into 2 subtrees. If 7 is a root node, so all the nodes before it will be placed in the right left subtree, and these nodes are the right child of that root node. In this way, every time we have to find out the root node from the pre-order traversal, and then identify the position of that node in the in-order traversal, and then divide the sequence in 2 parts. One is left subtree, another is right subtree. Clear? Yes, ma'am.
Yeah, madam.
In the next class we will practice some other example. In the next class we will try some other sequences. Okay, suppose post and in-order traversal is given, then we try to create the tree. Okay. So now, do you have any questions from today's discussion? No. No question. okay then. If you,
Madam, madam, actually, I have a question about the trees. As you know, all the nodes are moving towards one direction. That is it possible to having a two levels leaf node, two level which are in different nodes? Has it possible? The program, for example, 2 and 9.
2 and 9, okay.
Yeah, can that tree without connecting to without going through 514, can it just go through 2 and 9 directly in tree?
It's not possible because there is no parent-child relationship between these two nodes, isn't it?
Yes,
Two
ma'am.
and nine, they are not related, and it's a hierarchical relationship. And how we are placing these nodes in some hierarchy based on their relationship, isn't it?
Yes, ma'am.
Here, these two levels, 0 and 1. From this level, we have taken some branch to the lower level, 1, and we have created some parent-child relationship here.
Yes,
So between the nodes of two levels should have the relationship parent-child. Okay, after that we can suppose here, and it's not possible that we can just draw a line from 2 to 9. It's not possible because at that time 9 will have two parent, which is not possible.
madam. But we are when we are just arranging those things in order, do they looks like that?
It looks like, but you know the ordering, you know how we are actually traversing the nodes in that tree, isn't it? So if you know the sequence, then this type of confusions will not arise because you know how we are actually traversing that nodes in that sequence, in that traversal method. Although maybe we're taking 9 from 2 because of their appearance in that, or because of the sequence of that traversal method. But that doesn't mean that these two nodes, two adjacent nodes from any sequence of these traversal methods should have some relationship.
Yes, ma'am.
Clear? This is a hierarchical relationship, so only two level nodes can be directly related with each other. Here, only 2 and 14 are directly related with 5. We can't call 9 as the children of 5, but still they are related because from 9, or we can traverse 9 from 5, it's possible, but from 2 we can't traverse 9. This 5 can be our source node, 9 can be our destination node. We can traverse, we can visit node 5 to 9, but it's not possible from 2 to 9. But we can't call 9 as a child of 5. It's actually it's placed in the right subtree of 5, but there is no direct connection between 5 and 9. All two level nodes are directly connected.
Yes, ma'am. Madam, whenever we are putting in the list, that list sequence should be just like this one. Is it, madam?
Which list?
Madam, when we're gonna create a tree,
What type of list? Is it linked list or what you are actually talking?
link is madam, link.
Okay, so linked list is actually linear data structure where the sequence is not, it's not mandatory to place the elements in their contiguous memory location. So that means we can organize these nodes in linked list. It's possible, right? So at that time, how from where you can actually start
7.
7. Okay, so after taking 7, and actually it's a binary tree, or it's possible when you are taking a full binary tree, because at that time the sequence are fixed, that is 0 1 2, then 3 4. Here the left, without taking the left child you can't take the right child. That's why it will be more appropriate if we take a full binary tree. Okay, so suppose there is another node that is for 15. So this node number is 5.
Madam, but this is not complete,
Then-
don't you think?
Sorry, it's not.
Complete?
It's not complete.
Yeah, complete tree, madam. Because the leaf nodes the levels are not same. There's still holes.
Yeah, because we didn't take a full binary tree. When you can get a complete tree from a full binary tree. So this is just a binary tree. We have to make it full binary tree first. How we can make it? At first we have to take some child nodes of this node. So it's a long process actually. So I think we can discuss these things in the next class.
Yes, ma'am.
What do you think? Okay. So this is it for today, and thank you.